Right, 11.4, area integration. So this is where integration does get trickier. So the stuff we looked at last lecture, the definite integrals, the whole point of those is to work out the area under a graph. So, for example, if I had the following quadratic, let's just call it f of x, doesn't need to be a specific curve, and I wanted to find out the area between A and B, so let's call it region R. The area R would be the integral of f of x from A to B dx. So what integration does when it finds the area, so three really important points. Integration finds the area between the curve or the function, so this bit here, the x-axis, this bit here, and the limits, this bit here. So if you want to find this area, it's curve, limits, and the x-axis. And that's how it does it. It's so important to remember those key points so you don't get kind of caught out on these. So alternatively, we could have a quadratic here and want to find this area. Again, that area would be A, B, integral between the curve, the x-axis, and the limits. Or we could have something like this. Again, A, B, curve, x-axis, and the limits. So we'll find that area there. So we can use integration to find these areas between curves and the x-axis. And the only real way it gets tricky is if you forget what you're actually finding. Function, axis, limits. Function, axis, limits. That's the area that you're finding. Right, we'll try a few examples of this, going from easy to quite difficult. Okay, so on this question, try and find the area between that curve and the x-axis. So I've shaded the area there. Now, first thing we need is some limits. We need to tell the curve. We don't want to find all the area under it. We want to find the area from here to here. So we need to work out where this function crosses the x-axis. I could just use a calculator for this, but seeing as it's where it crosses the x-axis, we can make y equal 0. And if I rearrange and solve this, we get x minus 4, x plus 5. So my limits 4 and minus 5. So the way I'm going to find this area is to do the integral from minus 5 to 4 of 20 minus x squared dx. So 20 integrates to 20x. Minus x integrates to minus x squared over 2. Minus x squared integrates to minus x cubed over 3. And I put my limits in of 4 and minus 5. Now I just need to put these in and we'll have worked out the area. So 20 plus 4 minus 4 squared over 2 minus 4 cubed over 3. Subtract the other limit, 20 lots of minus 5 minus 5 squared over 2 minus 5 cubed over 3. Notice how I've used brackets loads, especially when I'm using minus. You've got to put it in brackets, otherwise you're going to make a mistake. That there is 100% correct. If you type it into your calculator wrong, you've still got all the marks bar that last mark. So if we work that out, you get 243 over 2, and we can check that on our calculator by typing this in with the limits and the integral. It should give us straight to the answer, 243 over 2. Cool, right, let's try some more exotic looking graphs. Right, so if you guys want to try this one, we've been given the sketch, we've been given the function, we've been given the limits, so you just need to work out what the area is. So if you want to pause it and try it, you can. I'll work my way through it now though. So it's the integral from 1 to 3. So again, integral between the curve, the x-axis and the limits. And my integral is going to be 3x plus 6x to the minus 2, because I need to bring that up, minus 5 dx. So integrate this, we get 3x squared over 2, x to the minus 1, so minus 6x minus 5x. Limits 1 and 3. Put 3 in, so you get 3 over 2 lots of 3 squared, minus 6 lots of 3 to the minus 1, minus 5 lots of 3. Take away 3 lots of 1 squared over 2, minus 6 lots of 1 to the minus 1, minus 5 lots of 1. If you work all that out, we get 6. So there you go. Check through if you get it wrong. We'll try a few more of these though. So another one, 0 and 3, again it's the area between the curve, the axis and the limit. So although the curve's underneath this time, it's still the area between the curve and the axis and the two limits. So if you want to pause it and try it, go for it. So integral, 0, 3, x squared minus 3x dx. The power goes up, x cubed over 3, power goes up minus 3 over 2x squared between 0 and 3. So we get 3 cubed over 3 minus 3 over 2 lots of 3 squared. Take away 0 minus 0. Just take away nothing. So for this one we get 27 over 3 minus 27 over 2. And the answer for this comes out as minus 27 over 6. Interestingly enough, we've got a negative area. Now, the difference is whenever you integrate something that's under the axis, the area comes out negative. So negative area. Now, area can't be negative, it doesn't make any sense. So we can just say the area is 27 over 6, just make it positive, everything's fine. Unless we have two separate regions. So in this case it's fine, negative area, just make it positive. In the next example you're going to see though, if we've got a bit of negative area and maybe a bit of positive area, things become a little bit trickier. So bear with me for this next one. Right, so in this next example, similar to ones before, the only problem is this bit's above the axis, so this is going to be a positive area. This bit's below the axis, so this bit's going to be a negative area. So if we just integrated from -3 to 1, it wouldn't work, because you'd have a big lump of positive plus a big lump of negative, and you'd actually end up finding that area minus that, which is not what we want. So if you need to find the area for something that goes above and below, you need to do two separate regions, or two separate integrals. So we're going to get the integral from -3 to 0, and that's going to be positive. Then, so if I label this positive bit, then we're going to do the negative bit. So we're going to integrate from 0 to 1, same thing. Make this one positive, and then we can finally add them together. Be careful, if you let your calculator do this from -3 to 1, it would give you the wrong answer. You have to split this up into two regions, because one bit's positive, one bit's negative. So if you want to try this, go for it. I'll work the way through it now as well though. Notice our integral's the same. So all that's different each time is the limit. So if we integrate this, we just steal the answer and just change the limits. So we're going to get x to the 4 over 4 plus 2/3 of x cubed minus 3 over 2 x squared. So square brackets, 0 minus 3 on the bottom there. This one's going to give us the same thing, so x4 over 4 plus 2/3 x cubed minus 3 over 2 x squared from 0 to 1. Now we've just got to work out the separate areas and put them together. So for this one, the first area is going to be 0. So put in 0, subtract the lower limit, so that's going to be -3 to the power 4 over 4 plus 2/3 minus 3 cubed minus 3 over 2 lots of minus 3 squared. And if you type all of this in, you get 45 over 4. Now we'll do the same thing over here. So we're going to get 1 over 4 plus 2/3, 1 cubed minus 3 over 2, 1 squared. Take away, put 0 in, and you're just going to get 0. So if we work out this bracket, I end up with -7 over 12. So my total area is going to be 45 over 4 over 4 plus 7 over 12. Because we know it's given us a negative, area has to be positive, so we can add those together. Do that on the calculator, and we get 71 over 6, which is the area shaded on the hard graph. Right. Yeah, cool. Does get slightly harder again. I might split this up into a next video, so if you want to have a look at that, do some practice on that, go over it, go for it. Last one, 11.5, it's going to be area between lines and curves.